In this lesson, we are going to apply what we have learned in previous lessons to looking at situational problems. So where might trigonometry be used in a situation? So we have, if the deck of a bridge is cracked or unsafe, it might need to be replaced. Renee is a bridge inspector, so she is calculating the length of the deck. What is the total length of deck needed between cable A and cable B? So she needs to find this total distance right here. Problem is, it is not in one right triangle. There are two right triangles, however, that we could use. So we're going to find each part. So we've got, in this particular right triangle, we have a length we can find. And in this particular right triangle, we could find this length. And then all you would need to do would be to add those together. So if we look at this, the first thing that we can do is we can find the length of x. We will label this triangle here. So we've got the hypotenuse. Across from the angle 50 that is given would be our opposite. And then beside that would be our adjacent. And our adjacent is 154. So we know adjacent is 154. We're looking for the opposite. So we're not going to be using the hypotenuse here. So we are looking at tan. So we have tan of 50. That was the angle measure. The opposite side is x. The adjacent side is 154. You use your calculator and you find tan of 50, and you get 1.1917 equals x over 154. We multiply by 154. So they will cross out here. And you will get a value of 183.5 equals x. So we have now found that first distance. Now we are going to look at the second triangle, and we are going to label. So we've got our hypotenuse. We are told that 56.5 degrees is the measure of this angle in here. So we go across from that. We have our opposite side, and then we have our adjacent is 154 again. So we know our adjacent. We're looking for our opposite. We don't need the hypotenuse. So once again, we are going to use tan. So we are looking at tan of 56.5. That was the angle measure we were given. The opposite is what we're looking for. And the adjacent is 154. Find tan of 56.5, and you get 1.5108 equals y over 154. Multiply both sides by 154. They will eliminate there. And we get 232.6 equals y. So now we know the length of that first part of the deck, which is x. We know the length of the second part of the deck, which is y. So we simply add these two values together. So we add them together, and we can tell Renee she needs 416.1 meters of deck between cable A and cable B. So that's one way that you could use trig functions in a situation. Let's have a look at another one. So taglines. These are essential safety equipment for using cranes. They are attached to the load of a crane to help steady the load and reduce the amount that it swings. So we have a crew of crane operators. They're moving a large piece of concrete sewer piping. Jeffrey and Frank each hold a tagline attached to the piece of piping. So we have down here, this is a J, so we've got Jeffrey, over here is F, we've got Frank. It's kind of hard to read. What we have here is a 62-degree angle. We've got 18 meters for this tagline and 21 meters for the tagline over here. So those are the values that are in that picture. The first question says, how high is the piping? So we want to know this value. We'll call it x. We want to know how high that piping is. If we look at the left triangle, there is not enough information. All we have is one side length, no angle measured. But if we look at the right side triangle, we have one side length plus we have an angle measure. So we have enough information to find the height of this piping. So if we label this triangle, we have our hypotenuse across from the 90 degree. Across from the angle we know is our opposite. Then we are looking for, we are not looking for it, but we also then have adjacent. Adjacent is useless. We know the hypotenuse, we're looking for the opposite. So we need to use our sine ratio. We know that the angle is 62 degrees. The opposite is what we are looking for. The hypotenuse is 18. So we find sine of 62 and we get 0.8829 is equal to x over 18. So now we multiply both sides by 18. 18s will eliminate, and we will get 15.89 equals x. So the height of the piping is 15.89 meters. Now we want to know, what is the angle of elevation of Jeffrey's tagline? So the angle of elevation works from the bottom up, so we are looking for this angle measure. We now have enough information because we do know that this height here is 15.89. So across from the 90 degree is our hypotenuse. Across from the angle we are looking for is our opposite. Then we have adjacent, which won't help us in this question. We know our opposite, we know our hypotenuse. So that is sine is opposite over hypotenuse. We are looking for the angle measure. The opposite side is 15.89. The hypotenuse is 21. So we divide those two numbers, and you end up with 0.7566. Then you use your calculator and you do your second sine. And so we get our angle measure is 49.2 degrees. So that would be the measure of the angle of elevation. So again, really similar information to what we did in our previous lessons, but now we've just attached a situation to it. Let's have a look at this last question here. It says the Fortis building stands next to TD Place in downtown St. John's, Newfoundland. The measurements are shown in the following diagram. We want to know what is the height of the Fortis building. So we have to look at what we know here. First of all, our ultimate goal is to find this height. How are we going to be able to do that? Well, the diagram kind of assists us. It shows us that we have some right triangles that we can deal with. What it also tells us is that the distance of the Fortis building, or stands next to TD Place, so TD Place is 148 feet. We're going to make the assumption that these are rectangular in shape, so this side would also be 148. So therefore, this part here is also 148. So we do know part of the height already. What we need to find out is this extra little piece. And so if we look at this here, that is this top right triangle that we are trying to find a missing piece for. Currently, we are told that the angle here is 33 degrees. Do we have a second piece of information? Because we need one more piece in order to find x. Well, actually, we do. Down here, between the two buildings, we are told that they are 60 feet apart. So therefore, this side here would also be 60. So now we can solve for x. And just because the diagram got pretty small, I'm going to draw that triangle again down here. So we know that this angle is 33, this side was 60 feet, and we're looking for x. Here was our right angle. So we can now label this triangle. Across from the 90 is our hypotenuse. Across from the angle is our opposite. And then adjacent is beside the angle. Hypotenuse is not going to help us here. We're looking for the opposite. We are given the adjacent. So we are going to be using tan. Tan is opposite over adjacent. We know that the angle is 33. Our opposite side is x. Our adjacent is 60. We use our calculator and we find tan 63 to be 0.6494. is equal to x over 60. We are going to multiply both sides by 60. So we will end up with 38.96 equals x. Now that is just the little part here that goes higher than TD place. So to find the total height of the fortis, we have to go 148 plus 38.96. And so we get the height of that building is 186.96 feet, or about 187 feet. So now you've seen how we can use trigonometry in some situational problems. So go and try a few of these in your practice.